Lines in the coordinate plane. Let's start with the warm-up. We're going to find the slope of the line that contains each pair of points. Now slope, I always think about my grandpa whenever I do slope. And the reason I think about him is when I was a little girl, he used to pretend like he was stuck in the basement and couldn't get out. And so we would walk hand in hand up the stairs saying up and over, up and over. He was quite a little comedian. And he would pretend like he was stuck in the basement until I would come to his rescue. So it's always rise over run, rise over run. If you think about climbing the stairs and you do run over rise, you're going to fall flat on your face. Kick your foot over and then lift it up. You're not going to be able to make it up the stairs very, very quickly, if at all. So it's always rise over run, or the change in the y's, y being our vertical coordinate and x being our horizontal coordinate. So it's the change in x's, the change in y's, difference of y's, over the difference of x's to find our slope. All right, number one, we have the point -2, 2, and the point 4, -2. To find the slope, we're going to find the difference of the y's. -2 minus 2, I looked at y and the y, over 4 minus -2, x and my x. When I go ahead and combine these now, I'm going to get -4 over 6, or -2/3. And what this means, as the line that contains those 2 points in number 1, the slope is down 2, right 3. Down 2, right 3. Number 2, I've got the points 3, 0, and 0, -5. Find the change in y's, -5 minus 0, over the change in x's, which is 0 minus 3. So once again, I put the y's together and then the x's together. -5 minus 0 gives me -5, and 0 minus 3 is -3. And that becomes positive 5/3. So the slope in number 2 is up 5, right 3. Up 5, right 3. Number 3, once again, change in y's, -4 minus -4, over the change in x's, which is 5 minus -3. This gives me 0 over 8. Well, 0 over anything is 0, so the slope is 0. The lines that have a slope of 0 are horizontal lines, so this tells me it's a horizontal line. The last one here, number 4, I've got the points -3, 3 and -3, 1. So I'm going to take 1 minus 3, that's my y minus the y, over x minus x, which is -3 over, -3 minus -3. This gives me -2 over 0. Well, anything over 0 is undefined. It can't divide by 0. So it's an undefined slope, or there's no slope. And lines that have no slope are vertical lines. So the undefined slope, those are vertical lines. The objectives for this lesson are to graph lines given their equations and to write equations of lines. Let's start by talking about some different forms that the equation of lines come in. We have the slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept, or the point where the line crosses the y-axis. Standard form of a linear equation is ax plus by equals c. A, b, and c are all real numbers. A and b, both of them can't be 0, which means you have to have at least an x and a y, x or a y coordinate. And a generally should be a positive number. A and b should be integers. All right, let's go ahead and graph the line y equals 3/4 x plus 2. I'm going to graph this one with knowing this is slope-intercept form. So my slope is 3/4, and b is 2, or the y-intercept is 2. When you graph a line, given the equation in slope-intercept form, the b tells you where to start on the y-axis. So start at the origin and then go up 2, since b is 2. If it's a negative 10, you go down 10. That's where your starting dot would go. Here I went up 2 because B was 2. And then from B, move in the direction of the slope. The slope is up 3, right 4. It's always rise over run. Lift your foot up and then move your foot over. So we're going to go up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. You can make more of those if you would like. Go up 3 and over 4, up 3 and over 4, and continue doing that. I suggest using a straight edge to connect those dots so that your line is a nice straight line. Graphing the line using the intercepts. Now in the last one we used the y-intercept. This is standard form, and we can very easily find the x-intercept and the y-intercept by letting the x be 0 and letting the y be 0. I'm going to let y be 0 and then I'm going to let x be 0. When y is 0, this is going to be the x-intercept. And when x is 0, it gives me the y-intercept. And we'll look at y here in a second. When y is 0, I have 6x plus 3 times 0 equals 12. 6x equals 12, or x equals 2. So the point 2, 0 means go over 2 and don't move up or down at all. That's why it's the x-intercept. The y value is 0. You're not moving off that x-axis, so it crosses the x-axis and it stays on the x-axis. X equals 2, start at the origin, go to the right 2. There's my first point. Now when x is 0, I have 6 times 0 plus 3y equals 12. Well, if 3y equals 12, y equals 4. So my y-intercept is when x is 0. You always let the opposite variable be 0, and that'll give you the appropriate intercept. I'm going to start at the origin. I'm going to move up 4. 1, 2, 3, and 4. Once again, I suggest using a straight edge to make a nice straight line. Yours will be probably straighter than mine. All right, transforming to slope-intercept form. That's a fancy way of saying, hey, solve for y. If it wants you to take a standard equation, in this case it's a standard equation, and put it into slope-intercept form, it's just asking you to make it y equals mx plus b. Solve for y. So we're going to start by getting y by itself. I'm going to subtract 4x on both sides. Negative 2y equals negative 4x plus 9. And then I'm going to divide everything by negative 2. So I'm going to end up with y equals 2x minus 9 halves. Remember when you do this to divide everything by that negative 2, not just the value in front of the x or not just the constant. Divide everything by negative 2 or whatever's in front of the y. Now I've got it in slope-intercept form, so I can see that the slope is 2. If the slope is an integer, you can always put it over 1. So 2 is the same as 2 over 1. And the y-intercept is negative 9 halves, or negative 4 and a half, or negative 4.5. So I'm going to start with my b. From the origin, I'm going to go down 4.5 units. 1, 2, 3, 4 and a half. And now I'm going to move in the direction of the slope, which is up 2 and over 1. When I move up 1, I'm still at the half. Up 2, I'm still at the half. And over 1. And then when I connect these two, that's the line of the equation 4x minus 2y equals 9. All right, point-slope form. If you're given a point and you're given a slope, you can find the equation of the line by plugging in your point and plugging in the slope. It's going to be y minus y1 equals m times the quantity x minus x1. Let's try one. It makes it a little bit easier to understand than all these letters if we use some numbers. Write an equation of the line through the point, negative 1, 4 with slope 3. All right, so the slope 3, that's my m. This is my x1. That's my y1. The equation of the slope, the equation of the line, so point-slope form, is to take y minus y1 equals m times x minus x1. Y and X are variables. They're going to stay variables. When we have the equation of the line, the final equation, we generally have an X and a Y, or at least one of those two. So those are just going to stay the letters X and Y. I have Y minus Y1, so Y minus 4, equals M, which is 3, times X minus X1. I'm going to distribute Y minus 4 equals 3X plus 3. Add 4 to both sides. Y equals 3X plus 7. This is the equation of the line in y-intercept form. If we want the equation of the line in standard form, what we're going to do is subtract 3x on both sides. So we'll have negative 3x plus y equals 7. And then to make that negative 3 a positive 3, we'll multiply everything by a negative 1. So 3x minus y equals negative 7. This is standard form, and the first one I came up with here was slope-intercept form. Okay, write an equation of the line that contains the points negative 2, 3, and 1, negative 1. Well, to start, let's go ahead and find the slope, because to use point-slope form, I need to have a point and the slope. M is equal to y minus y over x minus x, so I have negative 1 minus 3 all over 1 minus negative 2. This gives me negative 4 over 3, so the slope is negative 4/3. Now, to find the equation of the line, you get to pick. Do you want to use point A or point B? It won't matter. I'll use point A. Y minus y1, so y minus 3 equals the m, which is negative 4/3, times x minus x1, so x minus negative 2. This gives me y minus 3 equals negative 4/3 x minus 8/3. If I add 3 to both sides, I have 8/3. I've got a negative 8/3 plus 3. So that's negative 8/3 plus 9/3, which is 1/3. So the equation in slope-intercept form is y equals negative 4/3 x plus 1/3. If we would have used point B, we should get the same answer, and that's a nice way to check to see if you got it right or if you're not quite sure if you did the problem right. I'll try it with point B. Y minus y1, so that's y minus negative 1, equals m times x minus x1, so that's negative 4/3 times the quantity x minus 1. This gives me y plus 1 equals negative 4/3 x plus 4/3. And now when I subtract 1 on both sides, y equals negative 4/3 x. If I have 4/3 and I subtract a whole, so 4/3 minus 3/3 gives me 1/3. Looks like I did the problem right, so I got the same answer twice. So when you're finding the equation of the line and you're given 2 points, find the slope, then pick one of the points and plug it into point-slope form. Okay? Write the equations for the horizontal line and the vertical line that contain 2, 3. All right, let's think about what this is asking. The point 3, 2 is over 3 and up 2. The horizontal line is going to be right across from left to right, and that looks like it is at the point y equals 2. The vertical line is going to be up, down, and that is at the point of x equals 3. So the horizontal line going through the point 3, 2 is y equals 2, and the vertical line going through the point 3, 2 is x equals 3.